Good day, everyone. I am Neil Vincent Quaton,
And Arya Nicole F. Esperanza.
and today we will discuss how our body prevents blood loss whenever we get injured. Whenever we experience a small cut or even a bruise, our body immediately begins a process called hemostasis, which literally means the stopping of bleeding. This process involves three main steps: vascular spasm, platelet plug formation, and blood clotting.
Let's start with vascular spasm. Vascular spasm is an immediate but temporary tightening of a blood vessel. This occurs when the smooth muscle in the vessel wall contracts, causing the vessel to narrow or even close completely. This narrowing reduces blood flow to the injured area, which helps limit blood loss. This reaction is triggered by chemicals released from the damaged blood vessels and from platelets. For example, platelets release a substance called thromboxane, and the cells lining their vessels called endothelial cells release endothelin. Both of these chemicals stimulate the blood vessels to constrict, making vascular spasm the body's first line of defense against bleeding.
After vascular spasm comes the second step, platelet plug formation. A platelet plug is a temporary patch made of platelets that seal small breaks in the blood vessel wall. This step is especially important because tiny tears in blood vessels occur many times each day, and without platelets, even these small injuries could cause continuous bleeding. The process of platelet plug formation happens in three smaller steps. Step 1 is platelet adhesion. When the blood vessel is damaged, platelets stick to the collagen fibers that become exposed. A protein called von Willebrand factor helps platelet attach firmly by acting as a bridge between collagen and the platelets. Step 2 is the platelet release reaction. Once attached, the platelets becomes activated and release substances such as ADP and thromboxane. These chemicals attract and activate more platelets nearby, creating a positive feedback loop that rapidly increases the number of platelets at the injury site. Step 3 is platelet aggregation. Here, a blood protein called fibrinogen forms bridges between activated platelets, causing them to clump together. This clump of platelets forms a temporary plug that slows or stops minor bleeding.
Third and last process, the blood clotting, results in the formation of a fibrin clot, a network of thread-like protein fibers that trap blood cells and platelets, completely sealing the wound. This process relies on special proteins in the blood called clotting factors. These clotting factors normally remain inactive, but when a blood vessel is damaged, they are activated through a series of chemical reactions that occur in three stages. Stage 1 is the production of prothrombinase. This enzyme forms after several reactions triggered either by contact with damaged tissue or by chemicals released from the injured area. Stage 2 is thrombin production. Prothrombinase converts an inactive protein called prothrombin into its active form thrombin. Stage 3 is fibrin production. Thrombin converts another plasma protein, fibrinogen, into fibrin. The fibrin threads wave through the platelet plug, forming a strong and stable mesh that completely seals the break in the vessel.
As the blood vessel heals, the clot is no longer needed. Over time, the body gradually dissolves it, restoring normal blood flow. The bruise that may have formed earlier also fade as the trapped blood under the skin is reabsorbed.
To summarize, the body prevents blood loss through three main mechanisms. First, vascular spasm, which temporarily narrows the blood vessel. Second, platelet plug formation, which creates a temporary cell, and third, blood clotting, which produce a stable fibrin clot for complete protection.
That concludes our discussion for today. Thank you for your attention.
Stay safe and take care.